So just taking a look at the menus in this new Boland BV-07, which is clearly meant as an on-set monitor. It's so tiny, it's so wee. Very, very similar menu structure to previous model Bolands. The BVB7a is the one we know and love and sell a lot of. And to be honest, these menus are all very, very similar. Colour, temperature adjustment. I mean, these monitors normally are very close to Rec 709 out of the box, and I don't have to do much work to make them nice. But all the things you'd expect, picture-in-picture mode, because it's a dual-link gadget, and if you have two single-link inputs, you can set that so that you're displaying two pictures. But this is a new thing, maximum brightness, and a lot of these on-set kind of 7-inch monitors, they offer an HDR level of brightness, so much brighter than 100 candelas per metre squared. If I turn that off, kind of that's a post-production monitor, which in this brightly lit room really wouldn't be usable, or on a brightly lit set. But there, with maximum brightness on, it suddenly comes alive. Some of the other features, I mean, audio, much the same. You can de-embed and put the audio out of a little internal speaker, or out of the analog outputs on the back of the monitor, or the little headphone jack on the front. But in display, we've got the waveforms and the markers, which is all the things you'd expect from a broadcast monitor. But so using these function buttons, which I've already set up, we can put on digital meters for the audio, and you'll see there it's the sign-off SRI visualizer test chart is pipping away. But if I press that one, you can see the range of waveforms we can have, and we've got obviously digital audio meters, two groups of 8 channels. We've got a nice vector scope there, obviously a simulated vector scope because this is an SDI input, and a luminance histogram there, and a proper waveform. So this is a very competent, very capable little monitor. Another interesting feature is obviously it's got markers and several kinds of markers, but you can do underscan. So this is my test rig today. I've got the little Boland BVB7 on-set monitor with my Klein K10 probe. I'm feeding that with the output of a Blackmagic HyperDeck going via my Fuji IS Mini patch gen / LUT testing box, and just for starters I'm going to be using ChromaSurf, which is Klein's application for colorimetry. So I'm in a very brightly lit Route 6 boardroom at the moment, as you can see. So this is the ChromaSurf a display for the little Klein Mini that I'm testing at the moment. Currently I've got like a full screen white field up on the monitor, and you can see that out of the box, with no adjustments to the Klein, it's pretty close to where Rec 709 wants it to be. This is if I turn off the magnify function and go back to the good old CIE 1931 chromaticity chart, the tiny box in the centre there, we can see the black body locus scooting through that, and there's Rec 709 colour space and the overall CIE 1931 gamut. Excuse me. So let's zoom in on that. So we've got the big white box in the centre. The big white box is a just noticeable difference. That's kind of the limits of human perception. And hey, out of the box, straight from America, the Klein is bang on for the white point. I mean, you could possibly one notch adjust it to be a bit closer, but there's 6500 there, and there's 6504 where our television white lives. This is the black body locus sweeping through there. And if I take the slide down to a 10% grey, we can see that it's kind of getting a tiny bit noisier, as you'd expect, but still well within the neutral colour that we'd expect for this monitor. Now this is out of the box. The monitor seems to be set up for about 115 candelas per metre squared. If I was calibrating an edit monitor, I'd probably bring that down to 100 or maybe even 80 if I was at the BBC in a nice dim room. But one of the features of this monitor is that it's an on-set monitor, and so it has a hi-brite mode, which if I go into the menus, and you'll notice that changes the colour, because obviously there's menus now in the way of the probe, and I go down to the max brightness option and I turn that on, you'll see how much this monitor brights up. So now the probe is just pointing at that same white field, but look at this, we're getting more than 1,000 candelas per metre squared off this little monitor. Now obviously the colorimetry has gone out somewhat, and I'm not sure whether I'll try and pull that in or not. I'm not surprised by that at all, but for on-set use, this is fantastic. This is kind of as bright as you want it to be, around about 100 candelas per metre squared. And it looks great for broadcast colorimetry, so that's quite an impressive little monitor. Okay, so now we're in Microsoft Windows and we're using Lightspace CMS, which is the best color calibration software I've ever come across. I've still got the Fuji IS Mini connected as the patch generator stroke LUT box, and I've still got the Klein K10 probe connected, which are now connected to Lightspace. So if I just go and upload some null patches to the IS Mini, so that we've just got nice no LUT affected colour patches going to the IS Mini, and I go and look at my I just check my probe. My probe set to the Klein 10, you can see there, and let's go to the calibration interface, and what I want to do is a display characterization. So I don't have time to do a full 17-point LUT, but I can do maybe a 12-point LUT, which if the Klein can make one measurement per second, 12 times 12 times 12, divided by 60, because one measurement per second, that takes me down to about 28 minutes to do a 12-point LUT characterization. And so no LUT is enabled, so I should now be able to go measure. And I can see the 1931 chromaticity chart, and the calibration colour that's being sent to the IS Mini will be shown here. And I'll give this a name, BVB7a underscore test, and what's today, the 27th of May. And off it goes. Press OK to start. So this is going to take a little while, so I'll probably edit this down a bit. See colours being sent to the Klein. You'll have to take my word for it, but those colours are also being shown on the SDI output of the Fuji IS Mini as well. In fact, that's what Lightspace is measuring back from the probe. So see, as we go between colours, it makes a measurement and it updates it on the CIE 1931 chart. So let's just stop the recording there. So what did I say? I said 28 minutes, and it took 25 minutes 49 seconds. So that was pretty close. So let's close that down and let's go and take a look at the colour space that it derived. So there we go, BVB7a test. That's the one we've just done. And so there's our triangle, which, although my initial sort of grayscale calibration looked pretty good, looks like we've got something funny going on here. So let's have a look at the gammas. But having said that, the gammas are pretty close. That tracks very nicely. So nothing too bad going on. What else will show us something interesting? RGB separation again. That's much better than a Sony PVM-A250, for example. So let's we'll export that to. No, we won't. I'll do that later. So let's close that window. And let's go and do a color space conversion, and I will see how close I can get. I'll take Rec 7a as my target color space, and I will use the color space that we just derived from this monitor here. So that's all in order, and let's so I monitor a gamma of 2.35 as well, which as we all know is what Rec 8086 calls for. So let's create a LUT from that. 98% within target gamma. That's not great. I'd expect it to be a bit closer, but let's see what the cube looks like. Okay, so it's got lots of latitude in the blue end of the spectrum, lots of latitude, but as we saw, something's going on in the red end of things. So it would appear that this monitor has got great grayscale tracking. RGB linearity is fine, but it just can't quite hit the Rec 709 colour space in the red end of things. I wonder that's because it's an American monitor. They still handcrafted the days of NTSC, perhaps, where the reds were different. But yeah, there we go. That's our first kind of look at the performance of a Boland BV-7a, which is a little 7-inch on-set monitor. I think is exemplary. It's got that fantastic 1300 candela per meter squared option. For very bright on-set work, but it's also pretty close colour-wise, particularly in its sort of grayscale RGB tracking to Rec 709, just a bit out in the red end of the spectrum. But let's now try uploading this LUT into the Fuji IS Mini, and deselect null cube, because we want to upload the cube we've got in memory at the moment. And there it is. And so now I will go and take a look at some pictures through that. So here you can see the signal going via the Klein, and because the LUT's in circuit, it's obviously affecting the display now. If I press the LUT defeat button, you can see what that does to the images. It's a lot more evident on this little iPhone that's making the recording than it is to my eyes. But anyway, let's find some real pictures, not just colour bars. Again, there's not a great change in the colorimetry of the monitor. Maybe just desaturates the monitor a tiny bit. But I'm pretty impressed with how little work the LUT's having to do to pull this monitor to exactly Rec 709. And I can't kind of stress enough that expecting Rec 709 performance out of a little onset monitor is perhaps a bit much. It's quite amazing that this one gets as close as it does. Just on some flesh tones here. Barely has to do any work at all to make the pictures correct, as per what light space and the probe have measured. Good old test card F. See very little change going on there at all. Just look at the green dot top centre, just there. Just watch that green dot. Very modest change.